Given question, find moment of inertia along x-axis and y-axis for shaded area.
Let us understand the general procedure to find out centroid for any given shape. In this video, we have to find out moment of inertia of the shaded area with respect to x-axis and y-axis. How to calculate shaded area? If we divide this total area in the form of rectangle, in the form of triangle and semicircle, then shaded area is equal to area of rectangle plus area of triangle minus area of semicircle. So we will first prepare one table. First column is for shape. So we have to take this each shape, that is this rectangle, triangle and semicircle. Now second step, we have to select the centroid for each shape. So for the first shape, we will select the center. Now for this center, that is nothing but the centroid, we will show the axis. So here horizontal line is the x-axis passing through centroid, that is xc, and this vertical line is yc. Now we will find out distance from this centroid, from this base of the rectangle and this height of the rectangle. So I will show here with the help of dotted lines. So how to find out this distance? So if we observe, this is the center point. So this vertical distance 6 divided by 2, that is 3, and this horizontal distance 3 divided by 2, that is 1.5. Now we will move to the next, that is this triangle. So again we have to select the centroid. So centroid of a triangle we will show here with the help of this point, and then we will show the axis passing through centroid, that is this is xc and here is yc. Now how to find out the distance of the centroid from this base and height? So I will show here with the help of dotted lines. Now this horizontal distance is equal to 1 by 3 multiplied by base, that is 3 divided by 3, that is equal to 1, and this vertical distance is equal to 1 by 3 multiplied by height, that is 6 by 3, which is equal to 2. Now for semicircle we will select the centroid. So we have to select the middle point of this height, that is at a distance of 3, and we will select one point, and then we will show the axis, that is the x-axis and y-axis. So it is known as xc and yc. Now again we will find out the distance. So distance from this base and from this. So this horizontal distance, how to find out? So this horizontal distance is equal to 4r by 3 pi, where r is the radius. So horizontal distance is 1.27 and this vertical distance is the center of this height, that is equal to 3. Now we will move to the next column. We have to find out area. So how to find out area? Area of rectangle, base multiplied by height, that is 18. Then area of triangle, half multiplied by base multiplied by height, that is equal to 9. Then area of semicircle. So here is pi r square by 2, where r is 3. So pi multiplied by 9 divided by 2. So here is 14.13. So these are the areas. Now next is we have to find out the distance in between x-axis and xc, that is this line passing through centroid. Now why we are going to find out this parallel distance? Because we are going to use parallel axis theorem. We know the moment of inertia for each shape along the centroidal axis. But in this question we have to find out moment of inertia with respect to this x-axis and y-axis. So we are going to find out this distance in between x and xc in the same way distance in between y and yc for each shape. and then only we are going to use parallel axis theorem. So what is the distance in between x and xc? So it is equal to 3. Distance in between y and yc, it is equal to 1.5. In the same way, distance between x and xc for triangle, it is 2. Distance between y and yc, so in between this height and yc, it is 1, and the remaining distance, if we observe, it is 3. So 3 plus 1, that is 4. Then for semicircle, distance between x and xc, so this vertical distance is 3, and distance between this y axis and this yc, it is 1.27. Now in last video we have seen the moment of inertia for each shape along the centroidal axis. So we will write here moment of inertia about xc and moment of inertia about yc for each shape. So here first we will take Ixc, that is BD cube by 12. So here B is 3, D is 6. So we will calculate this. So 6 multiplied by 6 multiplied by 6, that is 216 multiplied by 3 divided by 12. That is 54. So here we have to take this as a 54. Now in the same way, dB cube, d into b cube by 12, that is the moment of inertia about this yc. So this is the centroidal moment of inertia. So we will take here d, that is 6 and 3 cube, 27 multiplied by 6 divided by 12, 13.5. Then next for triangle BH cube. So here H is this height, B is this base. So for B, 3 multiplied by 6 cube, 6 multiplied by 6 multiplied by 6, then multiplied by 3 divided by 36. So it is equal to 80. Then HB cube. So again H is the height and B cube is 3 multiplied by 3 multiplied by 3, that is 27 multiplied by 6 divided by 36, that is equal to 4.5. Now for semicircle. So for semicircle there are two types of semicircle. One semicircle with horizontal line as a base and the other semicircle with vertical line as a base. So this is the second type of semicircle. So here Ixc is pi by 8 r raised to 4. So we will first take pi multiplied by r raised to 4. R is 3. So 3 multiplied by 3, 4 times 3 divided by 8. That is 31.80, and 0.11 r raised to 4. So 0.11 multiplied by 4 times of 3, 8.91. We will calculate moment of inertia of shaded area along x-axis and y-axis. So moment of inertia of shaded area is equal to moment of inertia of shape 1 plus moment of inertia of shape 2 minus moment of inertia of shape number 3. Now we will first take moment of inertia along x-axis, that is equal to Ix, and which is equal to, so by parallel axis theorem we have to write this formula. So with reference to this table, we can use the columns, this Ixc, then Xxc and this area. So by using 3 columns, we will write the formula. Now we will first take moment of inertia of shape 1. Now it is Ixc1 because it is shape number 1. So we will take here Ixc1 plus A1 in bracket this distance xxc square. So this distance square we have to take, bracket complete. Now for shape number 2 we will write Ixc2 plus A2 xxc2 square. then minus Ixc3 plus A3xxc3 square. Now we will put the values are already calculated. So we will take 54 plus in the bracket, because we have to solve this bracket first, 18 multiplied by 3 square. Now in the same way we will put the remaining values, and answer is 111.01 meter raised to 4. Now in the same way we will move for Iy, that is the moment of inertia along y-axis. So we will use these columns Iyc, Yyc and this area. So we will write the formula. For shape number 1 we will take Iyc plus A1 Yyc square. So here Yyc1 square, because here is suffix 1 we have to use for shape number 1, plus for shape number 2 Iyc2 plus A2 square into Yyc2 square minus Iyc3 plus A3 in bracket Yyc3 square. So when we put the values, then we will get the answer 170.68 meter raised to 4.